Hey everyone, I hope I'm audible on Zoom.
Yes, we can hear you.
Okay, thanks for confirming. Thanks for being here, everyone. We maybe will wait one or few more minutes so that others can join in, and then we'll start. Okay, so a spectrum of good morning to good evening for everyone across the different parts of the world. Thanks for being here, joining us on the first orientation for the F1TENTH Sim Racing League. This one's for IROS 2024. Uh, Thanks for the participation. It was an overwhelming response where we have got 558 teams registered for this competition. So it's going to be thrilling race for everyone. So to get started with, we'll begin the orientation now. And since this is recording anyway to the cloud, we'll share the recording afterwards so that anyone who joins late can also view the parts that they have missed. So here is the list of organizers who have made it possible. While Chinmay and I will be doing most of the talking today, it wouldn't have been possible uh, to have this event without the support from all these people. So we want to kind of give a huge shout out to each and every person listed here, as well as people who have indirectly been a part of this whole F110th and auto drive communities. Uh, and to get in touch with any of us, there are a few methods and modes that we have highlighted on this slide here. First and foremost is the competition website, where we will be announcing or posting things related to the competition. These can be in terms of the events that will be going uh, and scheduled going forward, or the different kinds of announcements in terms of results or others. You can just use this QR code to go to the website. Again, we will make these slides available afterwards so that all of you have access to these resources. The second modality is the Slack channel, where we generally recommend people to join our Slack community so that not just us, but even you guys can start conversing with each other, potentially helping out each other in case of any technical issues. But this is where we'll be also posting announcements related to the competition, as well as having general discussions and helping some of the teams if they have any technical difficulties. If you have any core technical issues or kind of have some recommendations that can potentially improve the competition framework in the future iterations, you can use the GitHub repository to create an issue, a pull request, or a discussion. But for general type of questions, we generally prefer the Slack workspace. And finally, for things that cannot be posted publicly, you can contact Chinmay or me via our emails, but that's kind of the last resort, since some of the emails may get flagged spam and things like that. So what's on agenda today? Well, we'll be going over the competition overview. Then we'll talk about the different rules and regulations that are set forth for this competition. We'll talk about the different technical aspects of the competition framework. We have a live demo planned for you guys where we'll be walking you through the competition website in case of some details that you may have missed, as well as we'll be giving a live demo of the competition workflow, how to set it up, how to run it, and use it. And finally, there will be time for question and answers or general discussion where you guys can also feel free to participate. So let's first go over the competition overview. So the F1TENTH Sim Racing League, this iteration is a part of the 21st F1TENTH Autonomous Grand Prix. There is two races that's going to happen this year. One would be the Physical Racing League, for which 20 teams have already registered. This would be an in-person competition during IROS 2024, and they will be using physical F110 race cars in a physical racetrack at the event. And teams will qualify using a time trial, and then there will be a head-to-head racing event in multiple heats for teams to progress their rankings. This QR code will take you to the physical racing website. But specifically for today's discussion, we have the Sim Racing League. As I said, we have 58 teams that have registered. And this is going to be a virtual competition that's going to be held ahead of IROS 2024, approximately a week ahead of the actual competition. And here we'll be using virtual F110 race cars and virtual racetrack using the Autodrive simulator. And the format for this race is going to be time attack racing. We are keeping things intentionally easier for the first iteration of the competition so that participants can get accustomed to the competition framework, since this might be new for some of you. And this QR code will basically take you to the sim racing website. So to go over the different phases of the competition, first, I think most of you are aware of the registration part where you had to register yourself for participating in this sim racing league. Today we are at online orientation 1, where we'll be explaining the competition rules and guidelines and demonstrating how to use the simulation framework. But going ahead, we have the second orientation plan, which is approximately 2 weeks from now, where we'll check progress for each of your teams and can potentially help you with some technical difficulties if you're facing any. Then we'll have the qualification round where you will have to demonstrate 10 laps of consecutive autonomous racing. This can be slow speed, but you have to make sure that you don't collide too much or have at least basic algorithms ready for your final race. Once you qualify, approximately a week or two after that, we'll release the actual competition track where things might be a little bit different. So we advise each and every participating team to make sure that your algorithms are robust and adaptive enough to make sure that they can adapt to the changing track environments after we release the final competition track. And this will be only a few days before the final race, where during the final race, we'll collect the containerized algorithms from each of you and run them on our side. And then we'll record the performance metrics and publish them along with the results and standings of each of the teams. So date-wise and time-wise, this is the timeline that we are going to follow as of now. There might be some changes coming to this timeline due to unforeseen events or circumstances, but as of now, the timeline stands as is, where we are currently at online orientation 1 today. And as I said, 2 weeks after, 2 weeks from now, we'll have the second online orientation. On September 28th, you guys will be submitting the qualification race set up to us, and we'll convey the results back by 29th or 30th of the September. On 4th of October, we'll be releasing the actual competition racetrack, which gives you 1 day to fine-tune your algorithms on that racetrack. And on October 5th, you will have to basically give back the final algorithms in containerized forms, which will run on our side on October 6th. Potentially, since there is a lot of teams, we may take a few uh, more days, possibly October 7th and long stretch October 8th. But we'll make sure that on our end we be as efficient as possible to give you guys the results back as soon as possible. So in terms of competition resources, we have created and collated different resources for you guys. In terms of documentation, we have the competition rules and technical guide, which are available online publicly for everyone to refer to. We are also providing base containers for both the Autodrive simulator as well as the dev kit, which you guys can use to get started with developing your autonomous racing algorithms. In terms of uh, local resources, people who are finding containerization a bit overwhelming or are facing issues at the initial stages, for example, we have released the simulator as well as the dev kit binaries locally as well, where you can just download these resources on your local uh, laptops or PCs and start developing locally before worrying about containerization. You can worry about containerization in the later part when things get close to the submission deadline. Again, not too close because there are a few caveats and nuances with Docker that if you're using for the first time, you may, you know, invest a lot of time. And if you're doing that towards the very close to the deadline, then you might actually not be able to submit or finish containerizing your algorithms before the submission deadline. So just make a note of that you can do things locally, but at the same time start learning Docker and parallelly and trying to containerize your workflows as ahead of time as possible. And finally, we are going to also release the orientation resources, meaning the recording of this as well as the second orientation, as well as the slides. So you guys can feel free to refer how many of the times you want to get things cleared up. Okay, so now let's discuss the rules and regulations for the competition. First of all, we can refer you guys to this QR code here, where you can use this to go to the up-to-date rule documentation that's hosted on the competition website. But in general, there are three different categories or stages that we can define the rules in. One is the general guidelines for the competition, then the competition or race specific guidelines, and finally the submission guidelines. But there are three things that I want to highlight here. First is that, of course, the rules are subject to change. And that's why I said you can always refer to the up-to-date rules on the rule guidelines online, where we'll update them as and when required. But more importantly, there can be circumstances wherein we as organizers may have not anticipated certain things, and that's why we may have to amend or create rules on the go if the situation demands. And that's something that we'll, of course, post in the rule guidelines ahead of time so that everyone is aware of it. Finally, there is also two more things that I want to go over before moving to the next slide here. One is that please, because this is a global event, please be mindful of ethics and integrity and code of conduct before submitting your submissions or algorithms to us. If we find any unethical exploitation of the competition framework, or if there is plagiarism, if there is malpractice of any kind, we may disqualify that team and possibly also give a public citation on the competition website. So you don't want that to happen. So please be mindful of things or pitfalls, that you don't copy someone else's code, or you don't over exploit the simulation framework, etc. And lastly, as with any race or any competition, the race referee's decision is going to be final. But in extreme cases, you may submit rebuttals with supporting evidence, of course, and they can be entertained at the organizer's discretion. But we really don't want to go and do that for each and every team, of course. So coming to the general guidelines, most of you have registered, but just to go over the eligibility criteria again, this competition is open to everyone around the world. And that's not just for this IROS iteration, but coming up, we have a competition line for CDC. And there as well, we are keeping the registration open for everyone around the world. And it's free of cost as of now, since you guys are not going to use any conference or physical resources, but that may change going ahead. The competition structure will follow that we as organizers will provide each team with a standardization in the form of the standardized simulation setup as well as the APIs. And the teams, that is you guys, will have to develop the perception, planning, and control algorithms uh, without over exploiting the framework, of course, and then submit those algorithms back to us. The rule is simple. You have to go as fast as possible or try to minimize the lap time as much as possible without colliding too many times. In terms of the competition timeline, we, as I said earlier, will have the qualification race first, where you have to demonstrate that you can do 10 laps around the racetrack without colliding too many times. You can go slow, but not too slow, again, since this is a race. And then after you qualify, the time attack race will take place with a different track. And that's where you will really have to go as fast as possible, but again, without colliding too many times. In terms of the competition format, as again highlighted earlier, this is going to be a time attack racing where you will be racing against the clock independently, but on the same racetrack. That is, there will be no multiple cars or uh, participants racing at the same time, but we'll make sure that the racetrack and the environment is the same for each and every one of the teams, and that you guys are racing and competing fairly against the clock. So I'm saying 10 laps a lot of times here, but actually the competition, and that's more importantly for the final race, is going to be of 12 laps, where you will be starting with a warm-up lap. And as soon as you finish the warm-up lap, the timer for the competition metrics is going to start, where it's going to keep measuring the lap time unless you cross the finish line again. And let me highlight here, you cannot cheat by going in the opposite direction, for example, or just moving in the reverse direction as is, to cut the finish lap multiple times. We have set checkpoints along the racetrack that will make sure that you have to progress the entire racetrack before a lap is counted. And again, any over exploitation in this part, of course, will also lead to a disqualification. So we start with a warm-up lap, then you have to do 10 laps following that warm-up lap, and then you can choose to have a cool-down lap at the end, where we of course won't be measuring any collisions or the time during the first, that is warm-up, and the last, that is cool-down laps. But you can use these to start and fine-tune your localization algorithms, for example, in the warm-up lap, or do some cool acrobatics in the cool-down lap, which doesn't affect if you collide. In terms of the evaluation criteria, the ultimate evaluation criterion is going to be, of course, the total race time that you have for the 10 race laps. But in case that there is a tie with two or more teams, for example, we'll also consider other metrics in terms of best lap times or others. If you collide, you will incur a penalty that's going to be compounded each time of 10 seconds. So what that means is basically, if you collide first time, you're going to get a 10-second penalty. If you collide the second, you're going to directly get a 20-second penalty. That, of course, with your first penalty is going to be 30 seconds now. If you collide the third time, it's going to be 30 more seconds. That's total of 60 seconds, and so on. And there is, of course, going to be a maximum number of collision count that you can have before being disqualified. And that in this case is going to be 5. So across the 10 laps that you have here in the race laps, you can collide a maximum of 5 times. And of course, each time you collide, you're going to have a penalty. So the idea is that you collide as less as possible. And again, as I mentioned, the last thing is that the collisions or the times for the warm-up and cool-down laps will not be considered, but those for the 10 race laps in the middle will be considered as your performance metrics. Let's now go over the submission guidelines. In terms of the submission process, teams will have to containerize their algorithms and make sure that they are self-sustainable in terms of all the dependencies, libraries, etc. Using the Docker, and this should be done ahead of time and then submitted. You will have to push your Docker containers to the Docker Hub registry and share the link with us using a secure form. that will be disseminating close towards the deadline. In terms of submission privacy, we understand that this is a competition. You don't want your codes to be seen by others beforehand, etc. So here are a few guidelines or tips that you can follow throughout the competition. In terms of keeping your code base private, you can either, if you're a single person, for example, keep all the code locally without having it pushed anywhere online. But if you still want version control benefits of the cloud, you can host your source code in a private GitHub repository. GitHub does provide private repository access to all free members, so you can take benefit of that. In terms of keeping and storing your containers, you can again use Docker's private Docker Hub repositories to store your containers. As of today, Docker does provide one free private Docker Hub repository for each free registration. So even if you have a different account and you are using a Docker private repository for that, you can always create a new Docker Hub account, and that will give you an access to one more private repository where you can keep things for this competition. But after the competition, we encourage all the teams to make their source code, Docker images, as well as other race data like videos, logs. If you have any reports or papers, publications coming out of it, all of those publicly available, so that as a community, all of us can grow, and going forward, we can also raise the standards for this competition. So Chinmay will now go over the technical aspects of the competition framework.
Thank you very much, Tanmay. So in the first slide here, we have a video that you might have already seen on the competition website that depicts the F1TENTH digital twin. I'm not going to try to narrate what's happening in the video, but the high level takeaway here is that this video features a lot of things that are associated with the F1TENTH digital twin that we have implemented in Autodrive Simulator, but not necessarily all of these features or aspects are being exploited in the current iteration of the competition. So for example, you can currently see two vehicles racing at a time, which is very similar to the physical F1TENTH race. But to keep things simple for the first time, since most of you or some of you are not totally aware about the competition framework, and this is the very first time we are deploying it, we have kept him simple where just one vehicle will be racing at a time. And in the future iterations, we definitely do have a plan to now have multi-vehicle racing or other aspects that you might see covered in the video. The benefit of this framework that is also a parallel thread that related to reproducibility of results, etc., is that we are going to log all the metrics for all the teams, and we will be sharing them with you, of course. You can choose to analyze them to do two things. One is to refine your algorithms to improve your performance for the final race. And secondly, you can also use them to present a detailed analysis and potentially write technical reports or even research papers about the successive improvement of the implementation of your autonomous racing stack in general. So these are some of the interesting things. For example, you can see, for example, the FPV racing, which can also be done with human in the loop, for example. But one of the key things about the FPV camera view that you just saw is a similar camera view is also accessible via the API to all the teams right now. And you can feel free to use camera-based algorithms to now perform localization, for example, or help you in end-to-end navigation or any kind of tasks that you might feel to implement within your autonomous racing software stack that you will. So this is the most important part in terms of the technical aspects of the competition. We have released a very detailed technical guide. From the high level, it covers three aspects. One is the simulation framework, that is the simulator. Then we have details about the Autodrive Dev Kit, which is the ROS2 based API that we have implemented for this competition. And finally, some guidelines and details about the submission and execution of the competition in general. So there are two things again here that we would like to highlight. One is that we do expect all the teams or not necessarily all the members, but at least you have a team of different members who collectively have expertise in things like programming or understanding of autonomous systems in general, framework related knowledge and experience such as ROS2 or version control for example, GitHub, then for containerization, Docker, etc. You can also fairly easily acquire this knowledge. There are a lot of resources out there, so it shouldn't be too difficult. One thing that I would like to highlight here is, especially for teams that have multiple members, you can kind of tackle this problem by chunking it down into different aspects. For example, some members can focus on programming aspects. Some of you can focus more on the framework level aspects like ROS2, for example. One or two members can focus on version control of all the code base, and there could be one or two members who could now work on the containerization, get familiar and expert in that. And once all of the code base is ready, those members are now responsible to containerize everything and push to Docker. That's just an idea. Uh, Another thing here that's very important is we have highlighted the computational specifications of the kind that we will be deploying all of this computation framework on for evaluation of the performance of all the different teams. So please make sure that you do not, have dependencies on some high performance supercompute that may hinder your performance when we deploy it from our side. Finally, as Tanmay has highlighted multiple times, we have the QR code for taking you to the detailed technical guide, wherein all of the things that I'm just about to present are available, and like there is literally a lot of details on that. And I'll also be going over that during the demo section to, just make sure that you don't miss out on anything. So first, let us talk about the AutoDrive simulator. So in terms of the technical aspects here in the guide, what we have is first of all the system requirements that would be necessary for running this. Uh, I would like to highlight here that the simulation framework that we have developed is uh, flexible in terms of the computational resource requirements. So for example, you can see the toggle button for changing the graphics quality. You can do that if you don't have a very powerful GPU. Like first of all, the simulator is not very computationally intensive, so it should not be a very big problem or a challenge. But one thing related to that as a caveat is that you might want to make sure that you notify us if, for example, you are using a camera-based algorithm and you have trained your algorithm or tuned your algorithm in ultra quality mode, for example, or low quality mode. Then if that's changed, it might affect your performance. So, just make sure that you are aware about these kinds of caveats and pitfalls, potential pitfalls. In terms of the user interface, what you see on the left-hand side is the menu panel, and what you see on the right-hand side of this GUI is the heads-up display panel. In the menu panel, you can basically interact with the simulator. You can have a whole host of different controls here, for example, that you can configure the simulation. What I'm currently highlighting is the IP address and port number field and the connection button here, which is very necessary for you to establish the communication with the dev kit. Then we have other controls like engaging the vehicle in manual or autonomous mode, different camera views for rendering the on the front end of the simulator. Then, as I already mentioned, we have functionality to toggle the fidelity of the simulation in terms of its graphics to make sure that we are not consuming too many computational resources. We do have a scene light button here to control the environmental lighting, which can be turned on or off. It's something that you can use to test the robustness of your algorithm, for example. And then finally, we have two different buttons. One is to reset the simulation to initial conditions, and finally a quit button to exit the simulation altogether. On the heads-up display side, we have live display of all the different simulation parameters and vehicle stats in real time. We do have sensor streams and, for example, the camera view as well rendered there. And in terms of this competition specifically, since this is a racing event, we do also render the lap metrics in terms of the time and count in real time on the heads-up display. Finally, we do also have a data recording functionality, which will record time synchronized data in comma separated values and also grab and store the camera frames for you, which you can potentially use to train imitation learning algorithms, for example. In terms of vehicle, we have released the details pertaining to all the transforms of all the different components, uh, the high-level overview of the vehicle dynamics and sensor physics, as well as the details pertaining to the type of information that you would need to extract or you would need to provide to the simulation framework to make it run autonomously. And finally, we also have listed all the environmental details, which again cover the transforms, size and structure of the racetrack, as well as design and what kind of features you can expect in the racetrack. As Tanmay already highlighted, we have the Porto Racetrack Digital Twin shared publicly with you guys. And for the final race, which would be a different track, you can expect all these kinds of variabilities in terms of the uh, design and features of the track, but the size and structure would remain the same. Meaning, for example, the air ducts that you see in the environment currently laid out, uh, you can expect that the size of those kinds of things remains the same, which means that you don't have challenges in terms of perceiving them. But there might be things like we might intentionally have gaps or bifurcations, for example, to challenge the algorithms, but that won't be too much of a problem for the perception stack. In terms of dev kit, again, we have highlighted all the system requirements, both the minimum and the recommended system requirements. This is again a lightweight implementation, so you don't have to worry about needing a very high performance computer for running this. We also have highlighted the package structure for the Autodive front-end package, which is a ROS2 package. And one thing that I would like to highlight here again, and we have already listed this multiple times on the competition website, is that all of the teams will have to develop and implement their own packages that is separate from this package. You cannot modify the existing package in any way. That is not allowed. But of course, you can have access to the ROS topics that this package kind of exposes you to, and kind of subscribes to those topics and data streams to make sure that your algorithms are capable of running the vehicle autonomously. In terms of data streams that are available for the competition framework, we have released a detailed tabular representation of the different topics, the type of those topics in terms of if they can be used for debugging, if they can be used for for example, those are sensor topics or those are actuator topics. We have also detailed the type of message that they use for decoding the information, and also highlighted the access to those topics. So here access is very important in terms of the competition aspect. So certain topics are off the limits to be subscribed. We have also highlighted that on the competition website, which topics are input topics, which topics are output topics, and which topics are restricted. Most of the debugging kind of topics are restricted, meaning that you cannot or should not use them in your autonomous racing algorithms. You should not have subscribers to them, etc. And you can basically use them for offline things, but you should certainly not use any of that information while your algorithms are being deployed in the runtime, if that makes sense. Finally, in terms of the competition submissions, we have again detailed information and step-by-step instructions as well for setting up the containers, executing or running them, and also a few frequently required kind of troubleshooting tips that we have found useful throughout our deployment experiences. And then we also have a section that talks about how you could go about developing your algorithms, and finally, how you should containerize and submit the container images that you have built following the earlier process. So here we have a small graphic that is also, by the way, available in the technical guide, which depicts the competition framework from a high level. So what all the teams would be developing or working on is basically this small portion of the ROS2 packages or single package, whatever you like, that kind of implements all your autonomous racing software. And on a high level, what it's going to do is communicate with the devkit ROS2 package that we have developed and released. And via the ROS2 API here, it's going to communicate with the simulator container image, which will be running the F1TENTH digital twin in terms of both the vehicle as well as the racetrack. A good tip here that I think Tanmay already highlighted is, at least for us, during our initial work with Docker, is we can understand that it might be overwhelming for some of you. And in such a case, what you can do is you can work on the development aspect locally. We have also released the local resources as Tanmay highlighted earlier. And then finally, once everything is working and tested, you can then worry about the containerization and submission part. But especially with as I highlighted, teams with multiple people, what you can do is kind of divide and conquer here. You can have one or two people to get accustomed and experienced with Docker, so that you don't have a challenge during the deadline kind of times when all of it is working, but you just can't submit because nothing is containerized and it's kind of failing or something is happening. You definitely don't want that. Finally, it's time for live demo. I do see a few questions in the chat, but we'll just keep them for the last, and we will come back to all the questions, and we'll also have uh, a discussion uh, at the last stage of this orientation. So now let me take you through the competition website quickly. So this is the competition website that all of you are familiar with pretty much. There have been some updates recently, but most of it is still the same. You have a section here that talks about what this competition is. Then you have a section on the organizers, the timeline, the details of each of the events, and most importantly for you as participants, the resources that we have collected for you to get started and familiar with the competition framework itself. Then we have again a note here that kind of guides you through the process of communication. Then we have the registration details, and these are all of you who have been very helpful in making this event successful. And finally, we will be announcing the results later on the homepage of this competition website. Now, to talk a little bit more about the results, competition resources themselves. Here, as we were mentioning, we have the competition rulebook, which has detailed rules on all the different aspects of the general guidelines, for example. Then you have the competition guidelines, you have the terminology. We have been using certain words, you might not be familiar with them. What does lap mean? What does checkpoint mean, for example, etc. Then you have the details on how the execution of the competition framework will take place. There are some important rules regarding the inspection procedure, which I would again like to reiterate here. This competition is intended to be a battle of algorithms, so any modification to the existing competition framework in terms of the simulator or the dev kit is not permitted again. And malpractice or exploiting the competition framework and plagiarism and those kinds of things are again uh, not tolerated. I would again like to highlight a very important thing here. We do understand the benefit of open source ecosystem, and therefore you are very well allowed to use open source software and things like that. But in terms of acknowledging them is very important. That it's not your own work, it's someone else's work, so acknowledgement there becomes very necessary. So please make sure that you keep the licenses, for example, intact, and don't modify those things to adhere to those kinds of open source regulations. Then finally, we also have the details on evaluation criteria and the submission guidelines, submission procedure, privacy. Most of these things we already went over in this presentation, but further details are again available in the guide at your disposal. In the technical guide, we have, as I mentioned, detailed documentation about the competition framework. which covers things like the simulator, dev kit, and the submission workflow that I just highlighted in the slides. But we also have a video here published on YouTube and publicly available that kind of walks you through the a step-by-step tutorial for setting up and using the competition framework, which could be useful for you in terms of, if you forget something or you are not very well used to it by now, you can kind of refer to this video as many number of times as you want to make sure that everything is smooth. In terms of the simulator, we have, again, as I mentioned, the system requirements, then we have user interface details about the vehicle, such as the different transforms for most of the prominent components, the quantitative values of those transforms. Then we have vehicle dynamics information, parameters of the vehicle, actuator dynamics and its parameters. And finally, which is one of the most important things, is the sensor physics, what kind of sensors we have, what kind of data do they support, etc. All the different characteristics and parameters for these sensors. And then we have details about the environment. Again, here we have the transform. Then we have details about the size and structure, as well as the design and features about this environment. And then we move on to the dev kit, where you again start with the system requirements, the package structure, and most importantly, as I was saying, the data streams that you will be accessing. So the type and access restrictions are very important here. So some of these are debugging type messages, for example, what is the best lap time and collision count, or there are sensors like IMU and camera, for example, or there are actuators in terms of the steering and throttle commands that you can use. But some of these are now mentioned to be restricted, which means that you should not use them during the runtime. And we do have warnings, notes, and tips throughout these different documentations and competition website in general to help you, kind of understand and remember these different things. Then again, we have the details pertaining to the competition submission. So how do you set up the container? How do you execute them? And some of the important troubleshooting tips. How do you develop your autonomy algorithms? Again, this part is something that we want the teams to do. We have given some high level overview here, but all the teams should work on their perception planning and control algorithms implementation and containerization. We have tips about the general ideology and like the framework in general for you to work with, but we of course cannot help any team in terms of their algorithm development or formulations. So that's pretty obvious, but just wanted to highlight it anyway. Then we have a few step-by-step instructions on how do you containerize your implementation, how do you push those containers to Docker Hub, and of course, once you have them on the Docker Hub, similar to what the way we have the competition framework, you can of course submit the repository link via SQL Google Form, as I highlighted already. So let us now go back to the slides for a moment. Thank you, Tanmay. So that was the walkthrough of the competition website and the different resources that are important. The next thing that we have in the demo piece is the competition framework tutorial itself. As I already highlighted, we do have a recorded video about the setup and usage of the competition framework with detailed callouts and instructions on how to get started. This video is available publicly, and you can, as I mentioned, refer to it how many ever times you want. But right now, we will be doing more or less the same procedure live. There would be two things that I would be adding here. One is this is just a video only thing. That means it does not have any background narration, but I will be narrating the steps that I am currently going to take to do the same exact thing. And secondly, one of the things that, since this is just a framework tutorial, we don't have explicit details about the autonomous navigation piece here, but what I will be demonstrating right now, which I think is very useful, is how do you set the vehicle in autonomous mode and how do you control the vehicle from the API. So let us now move back to the see where I have the framework set up. So I'm hoping you can see the screen where you have the computation resources. So now here is where you will find the Docker container image for the simulator and the dev kit. This was like in terms of the website layout, it was a little bit different earlier, but we have just changed to make things organized here in general for the competition resources. So let me just close out a few things here, or we can just keep them running. So if we open the simulator container and the dev kit container, it will take you to the Docker Hub repositories, which you might have already tried out. But what we have here is, first of all, different things that you need for being able to do all of the things that we have listed later. One is you should have Docker installed on your system. And since the simulator requires access to the GPU, we also do recommend you to install NVIDIA Container Toolkit. This here is a final highlight in the sense that you will need the dev kit image to work with the simulator image, and you will need the simulator image to work with the dev kit image. Both of them are necessary. You cannot just use one. So I'll just start with the demo already. So this pull command is not going to do anything new here. One of the things that I want to highlight here is in terms of the instructions, we have a tag variable highlighted here, but it needs to be changed to the specific tag. It's a generalized instruction. So for example, 2024 IROS practice is one of the tags that you can use. And by the way, you can find all the tags here and their associated pull commands. So since I already have this image pulled, it did not do anything new for me. But if you see the video where I have done it for the first time, you would notice and you would also experience the same where the Docker will pull the container image from Docker Hub. Then the next step is to enable display forwarding. And finally, you go ahead and run the simulator. So again, here the tag should be changed to the specific tag that you have, for example, 2024 IROS practice. And this will launch the simulator container. We have set it up so that at entry point, it does launch the simulator executable directly. So you don't have to worry about any of those steps. So here we have the simulator running. Maybe I can change the graphics quality to ultra. And then you can also see all the live stats on the heads-up display. Now let us go back here to the dev kit container. Again, we have more or less same procedure here that we want to follow. First, we will pull the image. First, we will pull the image, then we will enable display forwarding, and then we will run the Docker container. So what this will do is, again, we have configured the entry point of the container to launch all the required nodes as well as RViz window for visualization. Now what I'm going to do next is very important. So I will, since I'm running all of this on the same PC, I don't need to configure the IP address or the port number, but if I'm running the simulator on a different PC and the dev kit on the different PC, then I need to first of all make sure that both of them are available on the same network. And then the PC that is running the dev kit, I'll need to find the IP address for that and then enter it here. Port number should be left the same since this is a port that is not mostly occupied. We are using 4567, and then the important thing here is to click on the connection button, which will change its status to connected, and then you have all the information from the vehicle available in real time view on RVs as well as the different topics. So if I just, for example, go a little bit forward, maybe I can just split the screen here, demonstrate what I want to. You can see that the vehicle pose and other sensor readings as well as the camera frames, for example, are being updated in real time. One final interesting thing here is that we do have a command for you that you can use to execute a bash session from within the container. So this is the name of the container within the API or the DevKit container I am now entering. So I can probably list all the files that I have. If I just go to source, this is the drive funded package, things like that. You can use this for implementing your algorithms. But what I'm about to do now is launch a teleoperation node. And that will enable me to control the vehicle in autonomous mode. By autonomous mode, I mean it will be listening to the dev kit or the API based software that you have developed to run the vehicle autonomously. So if you just go here, I launch, run the teleoperation node, you have the instructions of how to control the vehicle here. So one important thing again is to make sure to engage the vehicle here in autonomous mode for that to work. It will not work in the manual mode because in manual mode, it will be just listening to the HMI inputs that you provide from when you are working with the simulator window. But to make sure that the vehicle listens to the API commands, you have to set the vehicle to autonomous mode. And then, for example, I can hit W to make the vehicle run, or I can hit X to engage emergency brakes. I can also use A or D to control the steering and all these different commands. So it works in essentially the same way. So if I just kill this node and I do ROS to topic list, these are all the different topics. So for example, the node here was just commanding to these topics, publishing to these two topics to command the steering and throttle values for the vehicle. So that's it for the demo. You can exit the session. And that basically concludes the demo piece. So finally, here we have details about the Autodrive ecosystem as a whole in general, if you are interested. And we thank you everyone here for being patient the whole time. And we are now open to any questions and discussion. So start with the questions in chat. Are we open to use ROS packages? Well, we have currently restricted the dev kit for the competition to use ROS 2. I would like to highlight that there is ROS1 bridge, which can help you communicate between ROS1 and ROS2 topics. You can definitely use that if you want to develop your algorithms in ROS1. But the only reason we have not gone that route by default is ROS1, as you might all be aware, is coming to end of life the next year. So just to make sure that the competition is future-proof, the framework is developed that way. But you can, as I said, you can use ROS1 if you have your algorithms ready there. You can do two things. One is to port them to ROS2 if you have the time and interest. and the skills, or you can use the ROS1 bridge to make sure that the communication is intact. So the second question is, so are we downloading the F1TENTH package and creating our own package that taps on the data streams of the provided package? Not like creating ROS package to control agents in Gazebo. Yes, that is exactly what we are expecting of you. You will be downloading the DevKit container, but you will be writing your own packages to now interact with the different topics that I mentioned. For example, subscribing to different data sensor streams or publishing the actuator commands, etc. That should be done from an independent package. You should not modify the existing AutoDrive F1TENTH package. The next question is, how can we change map? Do we have access to transform of map to F1TENTH frame on the car? This helps to localize the car globally instead of local frame. You do have access to all of this information, but as I highlighted on the competition website, we have reference that all of these different things are debugging only, which means you can use them for understanding your vehicle performance, etc., but you should not use them to race autonomously. Localization using the transforms like the TF topics or using the IPS topic directly is not permitted. You will have to rely on sensing modalities like the encoders. For example, you can have encoder-based odometry, you can have LiDAR, point cloud, or visual feed from the camera that you can use to localize, but you should not directly exploit these restricted topics for localization. That's not permitted. In terms of the map, you can create the map using any of the mapping or SLAM packages out there. You can write your own algorithms. That would be I would recommend. I would not say highly encouraged, but that would be highly appreciated if you do that. And in terms of changing if this question alludes to changing the racetracks, that is not permitted as of now for the competition. We will be releasing the racetrack that we already have for the practice, and then the final race, that is the time attack racing event. The track for that will be released later. Will you provide the final track before the final race or make trial or stack? I'm not sure if I understand this question completely. I'll try to answer it anyway. We will be providing the competition track, that is the final race track before the racing event, and that has been highlighted clearly in the timeline. So if you look at the timeline, you will see the competition track released on October 4th, and then 5th and 6th is the final race. We intentionally do not want to have too much time between the track release and the final race. There might be a few changes by maybe 1 or 2 days there, but most likely we will be sticking with the same timeline. And the reason for that is to make sure that, the algorithms are just fine-tuned to work on the new track and not just, modified altogether, which means that they do not have any robustness or way of adapting to different tags. The IPS topic has access restricted and input. So can we use it during runtime? No, so restricted topics cannot be used during runtime. You can use IPS topic or the transforms, like the TF topic, from which you can listen to all the different transforms for debugging, like analyzing your algorithm performance, if you want to tune them in certain way, etc. You can also use them for training certain models if you want, but again, these should not be direct inputs to your model. This could be auxiliary inputs, for example, that the model does not necessarily require during the runtime. And in essence, restricted topics cannot be used during the runtime, but they could be used for debugging applications. The next question is, are we allowed to use the AutoWare stack? Should we expect gaps in this sidewall, multiple routes in the same track in the final race track? And should the vehicle be stopped at rest at endpoint of 12 laps? That's a very good question. So you are technically not permitted to use AutoWare stack, although the competition framework is based on ROS2. So you can use ROS2 based components since AutoWare based components, since that is also based on ROS2. The only thing is you will have to configure yourself the way you implement your packages and make sure that the publishing and subscribing is happening from your side. We do have resources, a whole host of resources for AutoWare, AutoDrive integration that you can potentially leverage, but there won't be any exclusive help, is what I mean, in terms of the documentation or things like that for you to implement that. There might be gaps or bifurcations, meaning multiple routes on the track that you have on the final race. We will try to keep things simple since this is the first ever deploy of this competition, but there might be certain variations and challenges that we will assess the autonomous racing algorithms that you guys develop on. And there is no strict requirement for the vehicle to come to a stop at the end of the 12th lap, but that is of course recommended and highly encouraged for you to do. So that's for the question. You can also perform, some fancy acrobatics and stunts in the final lap. That's the 12th lap, which is the cool down lap to, kind of show off, but that's all up to the competitors. What Linux distro was used and the ROS2 version in the dev container? We have used Ubuntu 20.04 with ROS2 Foxy in the container, but since it's containerized, it should not be any issue to run that. You can also use command line CLI commands to basically get to know the version of the ROS or the version of the operating system in the container, etc. So you are of course welcome to implement the algorithms the way you desire, and you can basically, as I mentioned, even in terms of ROS1 and this case ROS2 Foxy, you can basically have ROS2 topics that can now publish to the and subscribe to the same topics that the competition framework is allowing or accessing. Can the dev simulator be used with WSL or does it require dual boot? This does not typically require dual boot, but we do recommend working with Linux environments simply because of multiple reasons. One is that Docker is very easy to use in Linux environments. You don't need virtual machines or Docker desktop kind of things that will basically create challenges in terms of access to certain components of the hardware, for example, especially the GPUs, which is very tricky. And another thing to highlight here is in case you are having issues with accessing GPU via Docker, you can run the simulator locally as well, but the dev kit can be run in a container. They are still able to communicate with each other, and we have verified that. So you are very well welcome to go that route as well, where you can have WSL, for example, that is just running the dev kit container, and then you have the local Windows installation of the auto drive simulator, and then kind of develop and debug your algorithms that way. Is it a must to use Linux? Can we use Windows as Windows supports ROS2? You are very well welcome to do that. But again, as I said, it would be your responsibility, and so it would be your expertise necessarily to do that. We won't have exclusive documentation. We do have documentation that will be generally useful for all the teams. But for example, some of these different aspects like using AutoWare or developing with ROS2 on Windows, etc., you will have to take care of certain challenges if you face any. You do have a whole host of resources available for that, ROS discourse, etc., that you can use. Many people have tried that out, and I'm sure it works. And I hope really that it works for you guys as well. So it's not like it's not allowed. It's just that it's your responsibility to do that and take care of that. And finally, we want just the containerized algorithm. So we don't care how you guys develop them. We just want the containers that we will be, running in conjunction with the simulator to record all the different metrics for the competition, and based on which we will be assessing the different teams and creating the leaderboard. So I think I have covered all the questions in the chat. If there are any more questions that you want to ask in person by turning on your microphones, you can do that. If if you are not comfortable, you want to ask in the chat, you can do that as well. We will wait for a few more minutes to make sure that we have all the questions answered. And as Tanmay highlighted, you can of course use the different communication modalities like the Slack workspace, or if things are very personal and you cannot discuss them publicly, you can also email us in that case. But that's like the very last resort, as Tanmay highlighted, to get things clarified.
So I see one more question that you meant using Ubuntu 20.04 container that's only available to use Python 3.8 with ROS to Foxy, and that you find or think may be challenging. For this iteration of the competition, we have standardized the API to be ROS to Foxy. It will change or may change in the upcoming competitions, but for this competition, this is how it is, and that's common for all the teams. So it's not any unfair advantage for any particular team. If that's something that you can, you know, think about from organization perspective. And if there are any challenges, everyone will evenly and equally face them. So don't worry about facing some unique challenges related to ROS to Foxy, is what I mean. How can I import a map from .png or .yaml files? You cannot import the map. You will have to create the map. That's your responsibility, and that's a part of your autonomous racing algorithm. How you create the map, what algorithms you use, what parameters you use for the algorithms is completely left up to the teams. We give you the environment as what is done in the physical race, and you have to map out the racetrack if you are using map-based algorithms. Uh, and again, as I highlighted, developing maps is your responsibility. How you develop them is your responsibility. We don't look into them, those aspects, as long as they pass the inspection rounds. So we won't be providing the maps to you. We will be providing the environment in the simulation, and you will have to create your own maps, either using the LiDAR scans or using the camera, or if you have some innovative methods using other sensors as well. So while we wait for any more questions, one thing that I also want to highlight is the container submission tip, and that's kind of an important thing. That you will have to submit your containers in a way that they automatically start the autonomous racing algorithms. We on our side will not get into a bash session within the container or execute any commands for you. We have already showed how those things are done with the Docker container that we are shipping out as an image on the Docker Hub, where we are automatically spinning up some nodes, and we are also launching the RV session. We recommend everyone launch their own RV sessions so that when we record the videos for the individual teams, we also be logging all the metrics in a ROS bag, of course. But while we also record the videos, those things can now potentially help you gain more visibility when we post them or give them back to you. So I know we are slightly over time, and I don't want to take or keep anyone up, especially some parts of the world where there is night at the moment. Okay, we have one more question. Is there a race start topic? There is no race start topic. You have to finish one lap for the race laps to start. That is the warm-up lap. As soon as you finish the warm-up lap, the 10 race lap counter starts, and that is how the race will start.
Oh, sorry, can I
And after you
unmute?
complete the 10 laps, the timer will automatically stop. And the final lap, that's the 12th lap, is going to be your cool down lap. You can do anything that you want to do within the warm up and cool down laps. Typically, we recommend the warm up laps so that your localization algorithms kind of converge, and the cool down lap, you can do any fancy stuff you want. Of course, we don't recommend just hitting madly, but if that's something that you want to do, you can do that as well.
Yeah. My question was like, when we start, should there be a auto start script for launching our autonomous software, or when we launch our Docker itself, should it just start running?
So we'll
Or
wait
should
one more minute until 6:40 if anyone has any questions.
Um, I'll just answer the question I heard on the speakers. The question was, just to repeat, whether we will need to have an auto start kind of routine in the Docker container. Yes, as Tanmay highlighted just now, we expect that the team's containers are self-sufficient, not just in terms of the dependencies, etc., but also that they launch the necessary nodes, because we will not know the correct execution sequence, for example, or if you have different nodes that are dependent, to be launched, multiple nodes that you want to launch for making sure that the entire autonomous racing software stack is working together. We will not know that. So we expect that you create a launch file or some kind of a shell script, for example, that will basically at the entry point of the Docker container, launch all the things that is necessary. So once we, hit the connect button on the simulator after running the dev kit container that you have provided us, it will first of all establish the communication, and then the vehicle will just start racing. That is what we are expecting here. And again, to reiterate, the first lap that the vehicle will go through will not be recorded in terms of the performance metrics. As soon as the first lap is finished, that is the warm-up lap is finished, the vehicle will be, kind of not analyzed. It will be basically all the data from the vehicle will basically be recorded to make sure that we have all the different metrics logged, and based on those metrics, all the leaderboard positions will be decided. So the first lap is over. You have the next 10 laps in which the data is recorded, and finally the cool down lap again is something that you can use to cool down, shut down your algorithms properly, or maybe try some acrobatics, come to a safe stop, whatever you. All right, so I think since we are already a bit over time, we can conclude this orientation session. We do have another orientation session just 2 weeks later, where we can, potentially discuss some other questions that you might have from now to then. And as I mentioned again, you can have the Slack workspace or other ways to communicate with each other or with us to get your doubts or questions resolved at any point in time between as well. So thanks a lot again, everyone, for joining. And we hope that you enjoy this event and learn something out of it at the same time, potentially. And hope to see your container submissions soon. Thanks a lot, guys. Bye bye.